Welcome, ladies and gents. The first part of this video is going to be a little bit of a review of what we did yesterday in class. So yesterday we used an online simulation that helped us understand what is meant by this equation here, which is the molarity equation. Molarity is represented by the big letter M, and what it tells us is how many moles of solute we have in a certain liter of solution. So what I hope you guys saw in the animation yesterday is that when you put more stuff into your water, the molarity got bigger. And when you had less stuff in your water, the molarity got smaller, because this is a way that we can actually calculate how concentrated a solution is. So the more moles we have, the bigger the number is going to be. The less moles we have, the smaller the number is going to be. So it's all about how much stuff do you have dissolved in a certain volume of solution. So part of your homework was to try these 3 practice problems. So I provided my work for you guys, all based off this molarity equation. So what I'd like you to do right now is hit pause and look at my work. And anything that doesn't match, I'd like you to try and figure out where maybe you went wrong and how it compares to my work. Anything you cannot figure out the answer to, please write a question next to it, and I will make sure that I address it tomorrow for you at the beginning of class. So go ahead and hit pause and come back when you're done. Alright, so you're back, which means you're probably, hopefully, a little bit more confident with your molarity math. Now, the reason molarity is important is because it helps us as chemists basically stock our chemical supply rooms. We do a lot of labs in this class, which you guys have, really vocalized this week that you'll love so much. And we use a lot of solutions in those labs. So it doesn't really make sense for us to buy the specific solution that we need for every lab. It's better if we just buy one thing that we can use to make all the solutions that we could ever want. So we call that a standard solution. What a standard solution is it's a solution with a known concentration. So when Mr. Staub, Mr. Peterson, and myself start to buy chemicals for the next school year, what we'll do is we'll go through our stock room and figure out what we need more of. And oftentimes we need more of the different acids that we use in this class because we use those quite frequently. Now we use a lot of different molarities. Sometimes we use a 1 molar acid, sometimes we use a 0.1 molar acid, sometimes we use a 6 molar acid. So it wouldn't make sense for us to buy all those different concentrations. What we can do is we can just buy one standard solution and then use that to make all the different molarities we need for our lab. So the standard solution is going to be a guide that we can use to make all our different solutions with. The lab solution is going to be the diluted version of the standard solution that is used in the lab. So the example I like to use to explain these 2 vocab words is Gatorade. My husband is a big marathoner, and he used to run crazy races all during the year. And he would drink Gatorade during them to kind of replenish the electrolytes he was losing through sweating and then also hydrate. But what he realized is that if he just kept drinking full Gatorade all the time, it made his stomach a little bit sick. So he found out that if he took the Gatorade and added water to it, it allowed him to be able to drink the Gatorade but not feel so sick at the end of the race. So, for example, his standard solution was Gatorade. And then his lab solution would be the diluted Gatorade, or the watered down Gatorade. So your standard solution is just going to be the thing that's fully loaded, and your lab solution is going to be something that has water added to it. So you're just taking something and you're kind of diluting it down. So what does it mean when what does it mean when we do a dilution, and what are we really adding? So when we think about how my husband cut his Gatorade down, all he was doing is he was adding water. So what does that mean is really happening? So let's pretend that his Gatorade had a volume of 1 liter and that it had a concentration of 4 molar. So we're going to go ahead and we're just going to put 4 moles. So we know that molarity is moles per liter. So his molarity was 4 molar for his Gatorade. Now we know that he didn't like that fully loaded Gatorade, so he added even more water to it. So he took his water, all he did was take his Gatorade, and he added more water to it. So instead of it being only a liter in volume, maybe it was now 2 liters. But the only thing he added was water. So we still had those 4 moles. So if we think about the concentration, it's now 4 moles over 2 liters, which gets us to a 2 molar. So what you can see is that my husband, by adding the water, has decreased the concentration by half. So since when we're doing a dilution, we're only adding water, it's going to decrease the molarity because you have the same number of moles in a higher volume. So since these moles now have more water to spread through, it's going to be a less concentrated solution than what we started with. And so one thing we think about is we can think about the color of these things. If you think about Gatorades, if you have like red Gatorade, it's like bright, 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 stain your tongue red. And then when you add water to it, it kind of thins out that red and makes it a little bit lighter. So the dilute will have a very light color to it, while the concentrated will have a darker color to it. So what we can do is we can do some math problems with these types of dilution equations. And because the only thing that we're adding is water, is we can use what's called the dilution equation. The dilution equation is M1 V1 equals M2 V2, where the big M is molarity and the V is volume. The left side will be your standard side, so that's when we know the concentration, and the right side would be your dilute side. So this is going to be the side where water is added to it. So when we're doing these types of problems, what we do is we want to go ahead and we want to identify what pieces of the equation do we have, and we solve for the unknown variable. So for example, how many milliliters of a stock solution of 4 molar Ki would you need to prepare 250 milliliters of 760 molar Ki? So if I read through this, it tells me my stock solution, or my standard solution, is 4 molar. So this would be my M1. And I want to know what volume I would need to prepare 250 milliliters of this concentration. So this would be my V2, and this would be my M2. So I can go ahead and put those numbers into my dilution equation. So my M1 is 4.00 molar. I'm solving for my V1. My M2 is 0.760 molar. And the nice thing is, about this one, you don't have to change this dilution equation to liters. You can keep it in milliliters. That just means that the answer that you solve for would then be in milliliters as well. So now I'm just going to do algebra. Since my variable is on this side, I'm going to multiply my 0.760 times 250. And that gets me to an answer of 190. And because my variable's over here, I'm going to divide both sides by 4. So my V1 is going to equal 47.5 milliliters. So that's how much my stock solution I would need to put into my flask to go ahead and dilute it down to the desired concentration. So if we think about what these pictures are showing us here, this first picture is showing us that added stock solution going into the flask. So here I've got my stock solution that I'm going to dilute down. The second step is showing us that we're going to add enough water to get us to the desired volume. So in this case, I'd be raising my volume to 250. And that's how I'd end up with my less concentrated or lower molarity for my diluted equation. So we just add water to these 47.5 milliliters to decrease my concentration. So let's look at a second example. And this is where all the random disappearing pieces went. Alright, so I'm using that same dilution equation, so that same M1V1 equals M2V2. So for example, what volume of 18 molar sulfuric acid would be needed to prepare 1.5 liters of a 0.10 molar solution of H2SO4? So since this is my starting molarity, this would be my M1. And since these two go together, this would be my M2 and this would be my V2. So again, I'm solving for my V1. So I would put 18 molar times V1 equals 0.10 molar times 1.5 liter. So we would do 0.1 times 1.5 and get an answer and divide it by 18. And this gets us to an answer of 0.0083 liters, or we can simply change that to 8.3 milliliters. So that would be how much stock solution we needed to make this diluted solution. A secondary question we can ask is how much water did we add? So if we kind of draw a picture to think about what's happening, I know I want my final volume to be 1.5 liters. What this told me is that in order to make this dilution, I need to put in 8.3 milliliters of my stock solution. So that means that the rest of this water, that's going to get me to my volume, is all water. So I took that 8.3 milliliters of my concentrated solution and I added a whole bunch of water to dilute it down to that 0.1 molar concentration that I wanted. So how much water did I add? So if we think about this picture, if my total volume is 1.5 liters and 8.3 is that is my stock solution, I can subtract these two numbers to figure out how much water I added. But because this is milliliters and this is liters, the first thing I need to do is turn this to milliliters. So I'm going to do that times 1,000. That's going to get me 1,500 milliliters. I'm going to subtract the 8.3 milliliters, and that gets me roughly rounding to proper sig figs, 1,492 milliliters of water that I added. So we can see that this solution is mostly water and just a little bit of our stock solution. So these are the types of problems we can have for dilution. What I'd like you guys to do now is go ahead and show this so that you've completed your videos and get the practice worksheet to work on for the remainder of the period. If you've got any questions, you can always email me or ask me in class tomorrow. Have a great day, guys.